In this video, we're going to be taking an in-depth look at how you can create custom indicators in Backtesting.py. This is going to make it really easy to backtest any strategy that you can think of, because once you can create an indicator for it and translate your Python functions to something that works within the Backtesting.py ecosystem, it's super simple to arrange your buying and selling logic. I do already have a freely available course here on YouTube covering most aspects of Backtesting.py at a high level. So if you're completely new to the library, I'd recommend checking that out first, and then dig back into this video where we're going to focus mainly on indicator creation and a few different examples. I'm going to give 3 different examples which should cover most of your indicator ideas. The first one will be using signals that you've already generated in an external Python program and just plugging those signals into Backtesting.py. This is a really helpful kitchen sink option when you just can't figure out how to create your indicator within the ecosystem, but you've already got your buy and sell signals from an external source. In the second example, we're going to be dealing with pandas-ta and how we can return multiple values for each indicator. So I'm going to be using the Bollinger Bands and how we can return a data frame from our indicator rather than just a very simple NumPy array. So we can have the low and the high band rather than just one of them. And then finally, I'm just going to be hand coding a momentum strategy. And that's going to show us how we can create our own indicators just using pure Python, really. And so the sky's the limit once you understand these different forms. So without further ado, let's dig into our first example here. So I've got a virtual environment here in my terminal, and I've got everything that you might need to get installed. So, go ahead and install Backtesting, pandas, pandas-ta. I think that's most of the libraries we'll be needing today. So if you get those installed, you're good. And let's open up a Python file here. So I'll call mine example.py. So the first bit of code here is just going to be standard boilerplate when you're using Backtesting.py. So if we do from backtesting, import backtest and strategy. Those are 2 classes we're going to be making quite a lot of use of here. We can also import some data here straight from backtesting.py. So backtesting.test import goog. This gives us a data frame full of daily price data for Google stock. So if I go ahead and print that out, you can see it's a very simple open high, low close volume pandas data frame with a date time index. You can use your data in whatever format you want. You can grab it from Wi-Fi, from Polygon, from anywhere really. And it'll be much easier if you have it in a nice pandas data frame like this. And so, as I explained earlier, for this example, we're going to be assuming that you've generated some signals in an external program of some kind. So maybe you already have your indicators programmed in Python and you just want to transfer them over to Backtesting.py. Well, how would you do that? Well, let's make some signals here, just some random ones, it doesn't really matter, and we'll add them onto our data frame. So if I go Google here and then I say signal, and I set that equal to numpy.random.randint, we'll go from -1 to 2, and we want that to be the length of Google. We'll of course have to get numpy here for that to work, so import numpy as np. And if I run this, you can see we've now got some signals on the right. So this could be whatever fancy functions you've already built in Python. 1 is buy, -1 is sell, 0 is do nothing. So if you know how to get your indicator in this format, it's super simple to then plug that into Backtesting.py. So let's build an example strategy class here in order to do that. So I'm going to make a class and I'm going to call it signal strategy. Going to inherit from strategy that we imported just a minute ago. And then we need the two functions, which we always have in backtesting.py, and that's going to be init. And we also need next. Now, init's not going to actually have much to do in this particular example, but I'll leave it there anyway, just as good practice. And we'll have next here, self. I'll leave that as pass for now, just so that we can have this framework here. And then let's run our backtest at the bottom here. Obviously, nothing is going to happen. We don't have anything happening in our strategy class, but we can at least run it. And that way, it makes it easier for us to test. So we can do bt is equal to backtest. We then input our data. So in our case, it's going to be that Google Pandas data frame. Although for you, it can be anything you like. We're going to take our signal strategy. And we're going to set the cache is equal to 10,000. We can then run the backtest. We'll say stats is equal to bt.run. And we'll print out stats. So if I run this here, nothing happens, as you might expect. We don't get any trades. And obviously that's because we haven't actually implemented the buying logic yet. Now you might recall that in this next function here, we can do things like get the current price of an asset. So we can do self.data.close and then -1. And that's going to get you the most recent price of the asset. Let's print it out here so you can see what I'm talking about. If we go up, we see, all of these are just the stock price for Google on a particular day. The reason that works is because on every single bar, it's going to run this next function here with that day's worth of data alongside all the previous data. So if I get rid of the -1 here, or in fact, we can print the length of it, and that'll be more instructive. You can see that on every single day, the length of this closing price data expands by 1. So you can think about it, on the first day, you only have 1 day's worth of data. And then on the second day, you have 2 days worth of data. It runs the next function with that data. The third day, you have 3 bars worth of data. It runs the next function with 3 bars worth of data. And we run that all the way up to the very end of our data frame here. So I hope that makes sense in terms of how backtesting.py is drip feeding the closing price data into here. Now, what's so special about closing price? Couldn't we get the open price here? And indeed we can. You'll see, obviously I've printed out the length here, but it's also grabbing the open values from our Google data frame that we passed in earlier. And so because we have a signal column here, you can really, really easily pass that into backtesting.py. So if I do print self.data.signal, and let's just get the latest value here, you can see it prints 0, 0, -1, 0, 1, so on and so forth, all these random signals that I've generated. You're not just limited to signals here, of course. You can smuggle in basically any kind of pandas series that's inside your initial data frame. So if you've got some external indicator you want to bring into backtesting.py, this is a really, really great way of doing that. And so now we've got these signals, all we have to do is implement our buying and selling logic, which is pretty easy in backtesting.py. We can do it all within this next function, and it'll take like 5-10 lines of code. So we'll set the current signal here equal to the latest value from our signal series. That makes sense. Well, a value of 1 here is going to be buy. So I want to know if current signal is equal to 1. So if current signal is equal to 1, then we want to do some buying. But we only want to buy if we don't already have a position, because the way I'm structuring this bot, it just goes all in every single time. So what we can do is we can say if not self.position, then we want to buy. So self.by. This self.position here is quite handy. You can find it in the documentation. If you come over here, so you can see position here, and this gives the example here. So if self.position, that means we have some kind of position. It may be short, it may be long. And you can also do things like get whether it's a long position or a short position from this value here. So I can do, if not self.position.is underscore long, for example. It's quite a helpful little function so that you don't enter twice or mistakenly exit too early or anything of that nature. So if we get a signal of 1 and we don't currently have a position, then by. Otherwise, if the signal is equal to -1, well, in that case, we want to check if we have a position, and if we do have a position, then we want to sell it. So if self.position, self.position.close. You do have to be a little bit careful here. It's not actually self.sell here. So again, if we check the documentation, you can see self.sell here, so the sell function defined within strategy, actually places a short order. It doesn't actually close your position. So that's one thing to keep in mind. So this should be us done really for this example. I can run it here and then I'll also plot it out. So I'll do bt.plot. As you can see here, we have a bunch of random buys and sells. And in the end, even though it's literally randomly buying and selling, we still manage a 300, well, nearly a 400% gain in equity here. Interestingly, it doesn't draw down nearly as much as the buy and hold strategy would here, which is pretty funny. You get like 2/3 of the return with half the volatility, literally randomly buying and selling. Obviously, this doesn't include fees or anything. But this can also be a great way to test your strategies, just doing random here. So you could bring in your own signals from whatever sort of trading you've been doing already. And then you could compare that super easily to random buys and sells. Like I said before, this option is the kitchen sink approach. If you have some fancy machine learning model that spits out signals for you, but you don't know how to fit that within the Backtesting.py ecosystem, this can be a great way just to run those signals and backtest that particular pattern. It's important to be aware of how Backtesting.py executes orders. It executes the order on the next open. So for example, if you get a buy signal here, the buy will actually trigger on the open of the next bar. Equally, if this bar signals sell, it will actually sell on the open of the next bar. That's why the little tractor beam starts here. That's just an important fact to know if you're going to be dealing with Backtesting.py. So that was a super simple example based on you bringing your signals with you, having already pre-computed them. But what about if we want to make our own signals using some kind of external library or another program that we've written ourselves? How do we do that? In this section, I'm going to show you the most general way of doing that and how you can plug into pretty much any Python library that you want. So we're going to have to get rid of some of the code that we've got here. So let's go ahead and just scrap most of this. So we'll get rid of the signal here. We don't need that. And we'll also get rid of the random signals that we generate. We don't need those either. So we're back to regular Backtesting.py boilerplate here. So I'm going to be using pandas-ta here. You don't have to use a TA library. You can use anything that you like that analyzes a time series and returns another series of values. You can use something from scikit-learn, some statistical calculations. You can use anything you'd like. You don't have to use TA. So I'm going to be using the Bollinger Bands here. So we have to scroll down quite a way here, and you eventually find all the different things. If I just search B bands here, you'll find them. There are, of course, 1001 different indicators in here, so you'll be here a while. I'm using pandas-ta because it's a very common library. You can see it's got 74,000 downloads a month, and it seems to be really well liked in general. So let's go ahead and import that in our function here. So we'll import that, import pandas-ta as ta. We'll rename our strategy here. Let's call it a BB strategy for Bollinger Bands. And we'll make sure we update the name here. This time we're going to be using the init function over here because we can pre-compute the values of the Bollinger Bands based off the price. So anything that can be calculated at t equals 0, you want to put that in the init function ideally, because the init function's only going to be run once, whereas next is going to be computed on every single step. So ideally, you want to compute any metrics or indicators that you use within init. And so in here, we can do self.bbands. Well, that's going to be equal to self.I. We'll have our indicator in here, and we'll pass in our data. Now, what does this scary function do? Give me a second to explain. Self.I here is a function defined within this strategy class that we're inheriting from here. So it's just a regular Python function. It's just as if I'd gone here and I'd say, def, new function, self. It's just a new function like that. And it takes in some important parameters. So it takes in a function and our data. And at the end of the day, all it's really doing is it's returning our data with the function applied to it. So func data. Now the magic of an indicator when you define it like this is that it gets passed into the next function one bar at a time, very similarly to how our closing values were being passed in one at a time earlier. So on the 5th day, you get 5 bars. On the 6th day, you get 6 bars of indicator. And what this does is it eliminates look-ahead bias from a lot of our calculations, and it makes our backtest way more realistic. Because otherwise, it's really, really easy to fool yourself and convince yourself that you've got a good strategy when you're really just looking into the future. So that's a high-level view of what exactly this self.I does. It's going to take our data here and apply a function that we give to it. And if you look on the documentation, you'll see that it returns a numpy array of indicator values. Now you can return either a pandas data frame or a pandas series, and it will convert them for you. In fact, we can go into the code here and we can see exactly what the implementation of self.I is here. So if we go into Backtesting.py, you go to backtesting, you go to like roughly line 70 here, you'll see the definition of I. So it's within this strategy class that we're inheriting from. You can see it takes in a function which has to be a callable, and it returns a numpy array here. If you're really interested, you can dive down here into the details, but fundamentally, it's just a function that applies the function that you give it to the data that you give it, and then slowly and surely feeds that into next year. That's all this indicator function is doing. So with that out of the way, the next thing that we need to think about is this indicator function. And the really great thing is that this indicator function can be anything that you want that you can make in Python. So let's make a function here and I'll call it indicator. And it's going to take just some data. So I'll get rid of this other function here. So data is going to be our open, high, low, close data, which comes from this Google data frame here. But you don't have to pass in open, high, low, close data necessarily. You can pass in any data that you like that you can express in a pandas data frame. you can insert that into this object here that we're creating, and then you pull that through here and it goes into your function. So I hope that makes a little bit of sense. Basically, whatever data you put in here will be assigned to self.data, and therefore it's really, really easy to just shove it into this function, because this function is going to apply this function to this data. Okay, so we've got our open, high, low, close data. Now what I'm going to do here is I'm going to create the Bollinger Bands here using pandas-ta. So I'll say bbands is equal to ta.bbands. Close is equal to data.close.s. And I'll set the parameter here for the standard deviations equal to 1. That way it trades a bit more often. And let's print out bbands here. You may have noticed here that I did data.close.s. What that allows us to do is to grab the data as a pandas series as opposed to a numpy array. If you just try to grab data.close, you'll get a numpy array when this function takes in a series. So let's print that out and just see what happens. So as you can see, we've got our information here. Now pandas-ta is sometimes a little bit unclear about exactly what's happening here. In order to get further information and documentation, you basically have to pull up a Python terminal here, import pandas-ta, and then you can run the help function on anything that you like. So I'm going to run help on ta.bbands, and you can see it takes in the close, and then you can provide all of these alternate parameters here, these optional ones. And then if we go back here, we can see what it returns. So it returns the lower band, the mid band, the upper band, the width of the band, and the percentage size of the band. I'm only really interested in the lower and the upper here, but we can return the whole thing for now. So let's click enter here. And what I'm going to do is I'm going to return bbands.to_numpy. Self.i here does want to return a numpy array. So what this will do is it'll convert everything to a numpy array. So if I print that out, you can see here we've got a numpy array, which is just this that's been converted basically. You can return the data frame on its own. That's also fine. We can go and print it out here just to show. So print self.bbands. If we go over here, we can see it printed out. You'll notice the format's slightly different here. So this is the one that we assigned to self.bbands. Let me just go out here. So we've got two different versions. We've got the version that we're printing out inside the indicator function, and we've got the self.bbands here that we've assigned to this value. Those are two separate things. If I go out of this file here and have a look, the version that's calculated inside the function has each row equivalent to one row in the data frame. That's the default way that to_numpy works as a function. Whereas you notice the one that we assigned to self.bbands, this is looking very different. It's only got 5 rows and they're all very long. And so essentially what's happened is that this has been transposed. It's just an implementation detail of how self.i works. It prefers to use a column from here as a row. It can be confusing if you don't realize how it works, but once you realize that that's the trick, and indeed we can go in here and we can say, look, this 791 is equal to this. So the first column here is equal to this first row. This second column is equal to this second row, so on and so forth. You can keep going down here and you'll see that each column in here corresponds to one row because this ND array has been transposed. Interestingly, the same thing happens if we transpose our data here before we send it off. So I can do .to_numpy.t. So I'll transpose it myself. And you'll see that we still get the same data format. We still get exactly the same thing here. So you see that this is now the same as the one inside the function. Hopefully I'm making sense here. Try that out a few times yourself and you'll get the idea. What this lets us do actually is it lets us get rid of some of those other columns. So I can just go from 0 to 3 here. If I print that out, we now only have the first 3 rows in here, which correspond to the first 3 columns that are produced by our indicator. And if we go back to our pandas-ta thing here, we can see the first 3 are the lower, mid, and upper bands, which is what we want. I don't really care so much about the width of the bands or the percent. So I hope that makes sense to you in how I created this indicator from a pandas-ta function. Now you don't have to use pandas-ta here. You can use anything you want. As long as it returns a numpy array, you can do anything you like. And again, you're not even limited to ingesting open, high, low, close data. You can put in any kind of data you want into this object here, and you can read it inside here just fine. So you could insert sentiment data and have a read through that, do some statistical analysis on it inside your function, pass that into self.i as your indicator, and there you go, you have your indicator within backtesting.py that drip feeds the data into the next function so that we don't have any look-ahead bias. Hopefully this is all starting to make sense. Let's go ahead and just add some really quick buying and selling logic in here so that we can see this in action. So I'll get rid of these print statements. We'll say that the lower band is equal to self.bbands 0. So remember, the results of bbands here, each row in here represents one column in the initial data frame. So the lower band is going to be the first column, and then the upper band, which I also want, is going to be the second column. Or column with index 2 is actually going to be the third column. And exactly like every other indicator, these are going to be drip fed into the backtesting system one at a time. So we don't have to worry about look-ahead bias here. Okay, and so if we have a position, so if self.position here, I want to sell if the current price is greater than the upper band. So if self.data.close -1 is greater than the upper band -1. In that case, I want to do self.position.close like before. And if we don't have a position, well, I basically just want to do the opposite here. I want to check if the closing price is below the lower band, and in that case, I want to buy. So if self.data.close -1 is less than the lower band -1, then I want to do self.buy. You're of course not limited to just -1 here. You can do -2 if you want, or -3. You just grab bars that are progressively further back. So -1 is the last bar, -2 is the bar before that, -3 is the bar before that, etc., etc. So this should now do something at least. If I can spell everything correctly, so it's bbands, not bband. So I'll pull over the plot here, and you can see we've made a ton of different trades here. Of course, I just randomly use different indicators and values, so this is not really going to be a valid strategy. The point was to teach you how self.i works, so that you can make your own indicators with whatever libraries that you want in Python. Next up, I'm going to expand on that concept, and I'm just going to build a very simple momentum-based strategy using just basic Python and a bit of pandas. I'm not going to be using any TA, so a bit of a change from normal. So again, let's just get rid of all of this information here. We don't really need it. So we'll pass on here. We'll get rid of the B-bands. We don't need them. This is going to be a momentum strategy. I can go over here and let's just pass again in here. Okay, so let's go ahead and get started on our momentum indicator here. So we're taking in some data, and remember this is equal to this data. So whatever you pass in here, in my case, that's going to be open, high, low, close volume data. And so what I'm going to do here is my indicator is going to return the percentage increase in the value of the stock over the past 7 days. So in order to do that, pretty simple actually in pandas. So I'm going to do data.close.s. Remember, we want to grab it as a series. .% change. So this is just a basic pandas function. You can find that in the pandas documentation. And then I'm going to multiply those values by 100 because by default it returns them as decimal. So if I return that, and let's grab that function now in here. So we'll do self dot, say, percent change. Well, that's going to be equal to self.i. Then we have our function. So that's going to be indicator. So it's just going to be this value here, whatever you happen to set it to. And then also our data, so self.data. And if I print out self.percent change here, if I remember to change the strategy name down here, momentum, you can see over here we have just a bunch of different values. So obviously the first day we don't have any data on the previous day. The second day it goes up 8%. This day it goes up 1%, so on and so forth. If you look in the pandas documentation here, you can see we can set the number of periods here. So it's by default 1, so the 1 day change in price. I can just go change that here. So periods equal to 7, and that'll get me the weekly change in price. So as you can see, the first few values are all NAN because we don't have the previous week's price. And then after that, it does its own thing. So this is our momentum indicator that I'm going to use. Again, I built that using pure pandas. You can do any kind of manipulation to the data that you want here. You could look at the spreads between the open and the close. You could convert it to Heikin-Ashi candles. You could get some super intense ML bot to look at it. You can do anything that you like inside this function. Anything that you would do regularly in Python. So now we've got our indicator. Implementing our buying logic is super simple. Now, obviously, throughout this tutorial, I've been literally going all in when the indicator says go, and then selling everything when the indicator says no. You might not want to do that, or you might want to add in things like stop loss, take profit, that kind of thing. In that case, I'd recommend going back to, again, that free course that I mentioned here on YouTube. I'll leave a link in the description. That'll explain more about these general high-level concepts within Backtesting.py. For this video, I mainly wanted to focus on indicators, how you can create them, and why it's such a great part of the library. So let's quickly smash out this bit of code here. So I'm going to grab that indicator that we computed in init. I'm going to say change is equal to self.percent change -1. So I'm just going to grab the most recent value here. And if we have a position, and if the stock has decreased in price over the past 7 days, well, then I'm going to close my position. In our momentum strategy here, we're saying that the rally's over, basically. And then we can do the same thing down here. We can say else if change is greater than, say, 5%, we're going to count that as the start of some new rally. So we'll do self.buy. Again, backtesting.py makes it super easy to just add different conditions here. So I could also say and self.percent change -2 is greater than 5. So if today's price is greater than 5% more than it was the previous week, and yesterday's price also satisfies that condition, then and only then should you buy. You can do pretty cool things like that. Interestingly, if we go over to our equity curve here, you can see it did pretty well for some random strategy that I literally made up. Obviously, you're going to want to test this on a few different symbols here, but relatively low drawdown. And over the whole period, it did, nearly as good as the buy and hold strategy. So maybe momentum strategies do work sometimes. And so I hope that's cleared up for you how you can create custom indicators in Backtesting.py. Using any library that you want in Python, the sky is the limit.